Hey guys, welcome back to our channel Get Taste Soon. In this video, we are going to discuss the basics of linked list, and we're also going to see the types like singly linked list, doubly linked list, and circular linked list. So please stay tuned till the end. Now let's get started. A linked list is a linear data structure. Linear means which is not in the form of hierarchy, which is in the form of line. A linear data structure that connects elements through pointers. Just like the bogies are connected through some kind of media like magnets, the data inside the linked list are connected through pointers rather than storing them sequentially in memory. So when you open memory and see, they are not arranged next to each other. They are arranged randomly, but in a linear way. They're connected in a linear way. Now let's see how to do that, how it is possible. It is a sequence of interconnected nodes. Just like bogies here, in linked list we have nodes. Each node containing both data and reference to next node. This is a basic node structure. A node structure consists of two things. One is data, meaning its actual value. The second thing is next. Next is a pointer which stores the memory address of the next node in the sequence. So you might have one node in one row and the other node in fifth row. So how do you connect these two? Using the address of the next pointer saved in the current pointer, right? So with the help of storing this address, we are able to connect linked list nodes, just like bogies. Moving ahead, in the context of linked list, we have two things. One is head and null. Head node serves as a starting point for the linked list, the first data. And a null pointer is a final node indicating the linked list last pointer, that is linked list conclusion. Moving ahead, let's see singly linked list. Singly linked list is a basic form of linked list. So it follows only one direction, meaning unidirectional chain. So if the linked list follows from left to right, it is only from left to right, you can't travel from right to left. So we have a head, we have different nodes going in one direction, and we have a null. This basic format is known as singly linked list. Now let's see how to declare a node for singly linked list. As I already said, a node consists of two things, data and next. So into data. So this variable data is used to store the actual value of the node. Moving ahead, we have node next. Node next declares a reference variable named next, which is a type of node. So this variable is used to store a reference to the next node in the linked list. So what it contains basically, it contains the address of the next pointer. Moving ahead, we have a constructor with the node class, right? So constructor are usually special methods used to initialize objects when they're created. So here inside this constructor we have two things. This dot data, this dot next. So this dot data is equals to data, meaning we are assigning the value of data parameter to the data member. So it is used to track the current node. Similarly, we have this dot next, which is initialized to null. So when a node is created, it does not initially point to other node, right? So by default, we will initialize this dot next to null when we are creating a node. This is how we create node in singly linked list. Moving ahead, we have doubly linked list. A doubly linked list contains of three paths inside node. One is previous, data, next. You know, in single linked list, it is unidirectional, but doubly linked list is a bidirectional. You can flow from left to right or from right to left. Therefore, we have three things, that is previous, data, and next. Now, let's see how to define a node in doubly linked list. So, starting with the data, int data stores the data value inside node. Moving ahead, we are creating references to the next node in the list, that is forward, and we are creating the references to the previous node in the list, that is backward. Moving ahead, we have a constructor. The constructor initializes the node with given data. So this dot data is equals to sets the data value. After that, we are initializing forward and backward references. That is this dot next and this dot previous. When creating node, by default, we set the value to null. So this is how we create a node in doubly linked list. Moving ahead, we have circular linked list. A circular linked list is similar to singly linked list. The only difference is the last node in the next pointer is pointed back to the first node, forming a loop. As you can see in the picture here, in the last node next is connected to the head. So this makes a circular linked list. Now let's see how to define node for circular linked list. You know how to do the singly linked list, right? We have only two things inside node, that is data and the next. So creating the data and next variables. Once it is done, We'll create a node constructor and we'll give references. This dot data is equals to data and this dot next is equals to this. So if you notice in singly linked list, this dot next is equals to null because it points to the null pointer. But in circular linked list, the null pointer concept is not there. The last node's next is equals to the head. Therefore, we write this dot next is equals to this. So that's it from my side. Today in this video, we have discussed three types of linked list, how to create nodes for these three types of linked list. Thank you so much for watching till the end. If you have any doubts, please comment below. Please like this video, share this video and subscribe to our channel. Get placed soon. Thank you. Bye bye.